Hello and welcome. My name is Daniel Bott and I work at JUMO as an industry manager for temperature probes for heat and cold meters. In this video I would like to show you how important the correct installation of temperature probes is when installing heat and cold meters. In particular, I will highlight the differences between symmetrical and asymmetrical installation and effects such as the heat conduction error. This may sound a bit technical, but I promise it's worth taking a closer look, especially if you want to ensure accurate temperature measurement. Let's talk about precisely this heat conduction error in a moment. An issue that is often underestimated, but it's crucial for measuring accuracy and therefore for billing heating costs. Let's imagine that a temperature probe measures a temperature, but due to incorrect installation or external influences, it does not measure the temperature of the medium, but a different or incorrect temperature. The problem occurs particularly when there is a large delta between the measured temperature and the ambient temperature. A temperature gradient then occurs within the sensor, causing a heat flow. The sensor element is therefore either heated or cooled, and this means that the sensor no longer measures the actual temperature of the medium, but instead displays falsified values. This effect is not just a minor problem. Even small deviations can lead to considerable errors, resulting in serious measurement errors, especially in precise applications such as heat or cold meters. Another factor that is often not considered is the use of so-called immersion sleeves or called pockets. These pockets protect the temperature probe and make it more robust, but they also affect the measuring accuracy. How exactly? The length of the pocket and its internal diameter play a key role. A pocket is an additional thermal resistance. The temperature probe is less well coupled to the true temperature, and the pocket has an additional heat conduction error. The heat conduction error is particularly pronounced with shorter pockets. However, the height of the hexagon, the wall thickness, and the tolerance of the inner diameter of the pocket also determine how precise the measurement is. In practice, this means that you have to think carefully about which pocket you use, if you need one at all. You should definitely always give preference to direct installation, so that the temperature sensor is directly surrounded by the measuring medium. Such a ball valve with probe installation point, which is even standardized, is suitable for this purpose. Particularly in cooling applications, where the temperature differences are often extremely small, inaccurate measurements can have a significant impact on the billing result. Let's now move to another important point: the difference between symmetrical and asymmetrical installation of temperature probes. In symmetrical installations, both probes are mounted in the same way, either both directly in the medium or both in pockets. This symmetrical arrangement ensures that both probes measure the temperature under almost the same conditions, an important condition for accurate measured values. Asymmetrical installation, on the other hand, means that one probe is installed directly in the medium, while the other is in a pocket. This difference in the installation occurs an additional error. The different heat conduction error of the installation points causes an additional error when measuring the temperature difference between flow and return. The lower the flow velocity of the medium, the higher is the error. This can be in the order of magnitude of 1 MPE or even significantly higher. This influences the measuring accuracy and, in the worst case, can lead to incorrect billing values. You might now ask yourself, why should you install asymmetrically at all if it can lead to errors? This answer often lies in the simplification of the installation. Many manufacturers of heat and cold meters already integrate a temperature probe in the volume measuring section, thus saving an additional installation point. This sounds practical at first, but is often associated with lower measuring accuracy if other temperature probe is installed in a pocket. Even with symmetrical installation, for example, one probe in the volume measuring part and the other in the ball valve, there can still be a small error. This is because the volumetric measuring part may have a higher heat conduction error than the ball valve. As a rule, the manufacturers of heat and cold meters have this tested once as part of the type examination certificate. To avoid billing errors, we carry out tests at JUMO. We examine both symmetrical and asymmetrical installations in various scenarios. For example, we test probes with and without pockets at different flow velocities. The aim of these tests is to qualify the influences of the different types of installation. If the influence is known, this can be taken into account by the meter manufacturer. As a rule, the operating conditions are then later restricted for these installation situations. This can be done via the delta theta min or the minimum flow rate. In summary, it can be said that the installation of temperature probes, whether symmetrical or asymmetrical, has a major influence on the accuracy of the measurement. The heat conduction error in particular, which unfortunately you cannot see with your eyes, has a major influence on the calculation. However, with these basic principles mentioned here, you can ensure and practice that the measured values really do correspond to the actual energy consumption. Thank you for watching, and if you have any further questions on this topic or need a customized solution for your system, we at JUMO will be happy to help you. See you next time.